Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from probability and statistics. This particular question belongs to paper 9709/55 for the session May June 25. Let's read the last of all question of this paper. A darts club has 12 members made up of 7 men and 5 women. Every Monday, a team of 4 is chosen at random to represent the club in a competition. Find the probability that on a particular Monday, the team consists of 1 man and 3 women. Let's start the solution. So, here the concept we know is it is all about selection. So we are going to apply the concept of combination. Okay, so let us see how many selections can be made if there is no restrictions. So first of all, we will write number of total selections, number of total selections, total choices or selections, whatever you write, selections. Total there are 12. Okay, total number of member is 12, out of which 7 are men and 5 are women. So from 7, if we choose only 4, okay, from 12, if we choose 4, it is just 12 choose 4, okay, then it is going to be 12 factorial over 4 factorial as well as 8 factorial. If we use our calculator, it will show 495 choices. Okay, then they have told to find the probability when the team consists of 1 man and 3 women. So their total number of men is 7. Out of 7 we will choose only 1, and out of 5 women we will choose only 3 women. So let us write number of selections, number of selections with restrictions, with restrictions, with restrictions, with restriction. Number of selections is equal total selection. Here we can use equal symbol. So here also we are going to use the same symbol, equal symbol. Okay, so equal to what? First of all, we will have to choose 1 from 7 men. Look at this, it is written total number of men is 7. From 7 we are going to choose 1. 7 choose 1, and out of 5 women we are going to choose 3 women. So 5 choose 3 women. Let us do the calculation. If we keep on calculating, it is going to be, let me write just beside this, it is equal to 7 choose 1 is actually 7. Okay, you know, and 5 choose 3 we can be writing 5 factorial over 3 factorial into 2 factorials. You know how to write this. Let us calculate this. This is going to be, well, 5 factorial means 120. Let us expand 5 factorials. 5 into 4 into 3 factorial. I am doing it manually actually. You can use calculator for shortcut. So 3 factorial can be dissolved by the other one. So this is 2 factorial means 2. So 20 and 2, 20 divided 10. So it is going to be 70. 7 tens are 70. Well, now here there is a clue. We should not ignore the question. Question didn't tell us to find the number of selections. If you look at this, it is actually find the probability. They have told us to find the probability. So for probability, it's very simple. We will divide the number of selections with restriction divided by with no restrictions. So let us write the probability. I think I can write just over here. Okay, hence probability is equal to, if we write, hence probability is equal to, probability is equal to, we will just divide the number of selections with restriction by number of selections without any restrictions. So it is 70 over 495, 9 as well as 5. So finally our probability is going to be, if we use our calculator, we will get 0.1414. That means if we round it up to three significant figures, it is 0.141 equal to 0.141. So that is what the answer to the first part. This was actually very simple question. Let's move on to the immediate next question. The immediate next question says that every Tuesday, the darts club chooses three teams of four. Each team enters a competition in a different town. In how many different ways can the team be chosen if there are no restrictions? Look, this question is also about selections. Look at this, number of ways means it is also about selection. So for selections, we know we are going to apply the concept of combination, not permutation at all, because arrangement is not sought here. So there are three teams and each team will contain four members. So simply we can write number of selections, number of selections, number of selections is equal to, look, there are three teams, each team will contain four members, so total number of members is 12. We know 7 plus 5, 12. So out of 12, in the first team we are giving four members. Then there comes the second team has already 4 has gone away, so there remains 8 members. Out of 8 we are choosing again 4 for the second team, and for the third team actually there are only 4 members, out of which all of them should be chosen. So it is going to be, if we write 12 factorial over 4 into 8 factor, 4 factorial into 8 factorial, first quantity. Then second one is 8 factorial over 4 factorial into 4 factorial, you know how to write this, into 4 choose 4 is actually 1. Okay, you know this. If equal number of member or object is chosen from total is 1, then if we use our calculator, let us use our calculator, it is 12 factorial over into 8 factorial over 12 factorial to 8 factorial over 4844. 4844 we will divide by 4844. So 4 factorial into answer is going to be 34,650 ways the three teams can be chosen. It's there is nothing difficult to understand this. I believe that all of you have understood both of the solution of this page, because these are the two of the simplest of all solutions. Okay, well, let's move on to the question number C. Question number C is printed on the next page. Yes, it is number C. So for C, we will have to find in how many different ways can the teams be chosen if each team must contain at least one man and at least one woman. So there we should not forget that in the previous one there were three teams. Actually, we are still under the question of this one. We are under this statement. Okay, this is our scenario. Every Tuesday, the Darts Club chooses three teams. Remember, there will be three teams of four. Well, now for these one, three teams of four. So how many ways different in how many different ways there will be three teams, and the condition is at least one man and at least one woman. So let us find the probabilities. Let us write total team 1. Suppose this is team 1, T1, then team 2, team 2, then team 3. There are three teams. Okay. So for the first team, we can choose, suppose there are three men, as there should be total four. Remember, we should not deviate from the question. They have told in each team there will be total number of members will be four. So if three men, then there will be one women for the first team. And for the second team also we can choose, so three men and one women. Okay. Then for the third team, let us see how many are left. Total, there were seven men. Out of seven men, three men plus three men, six men have already gone away. So there remains only one man. And out of five women, one plus one, two went away. So there are three women. So this is the first case. Okay. So for the second case, we can choose two men and two women. Okay, for the second team also we can find two men and two women, two men, two women. So four, and now let's see how many are left. Total there were seven men, so out of seven, four has been chosen, three is to be chosen here. Three men and two plus two, four went away, only one women is left. So these are the two possible cases of the selection. Now we are going to write, hence number of selections, but I can write just beside this number of selections, it can be written here. Look, first there are how many men are there? There are seven men. Out of seven we have chosen three, so seven choose three into one women, one out of five, so it is going to be five choose one. We have chosen one. This is for the first team. Please don't forget that we will have to form all of the teams simultaneously. That's why it is multiplication, not or, remember. So for the second team, it was for the first team in the first possibility. So first team, well, for the second team, as we are forming all of the teams simultaneously, so it is multiplication. For the second team, three men out of seven. So seven choose three, and sorry, it's not a seven because already three men has been taken. So it is not seven men left. There are only four men left. So we'll have to write four choose three. This is for the second team. Please don't get deviate from the fact. Then there is one woman. Out of what? One woman has gone away from five, so there remains four. Four choose one. Second team has, this was the first team and this is the second team. Then for the third team, how many men are left? 3 plus 3, 6 went away. There is only one. Oh, sorry, 6 has gone away. So there remains only one man. So from 1 we are choosing 1. 1 choose 1. And let's see women. So one women, two women went away. So there remains only three women. And out of three we have chosen all three. So it is 3 choose 3. 3 choose 3. So this is the third team. Please don't get confused with this. This is the calculation of first team, second team, as well as third team. Well, let's see whether I do have space on the right side or not. Okay, I don't have space for the right in the right side. Okay, for the second possibility, let us write for the second possibility. For the second possibility, let's see first team. So for the first team, what is it going to be? For the first team, total there are 7 men. Out of 7, we have chosen 2. So 7 choose 2 into, this is for the first team. 7 choose 2, and 2 women out of 5. Out of 5, we have chosen 2. First team has gone away. This is the first team. Then second team. For the second team, we are choosing already out of 7, 2 has to have gone away. So it is going to be 5. From 5, we will choose again 2 men. Then women for the second team. For the second team, this is for the second team. Okay. So 2 women, already 2 have gone away. So there remains 3. So it is going to be 3 women. From 3 we are choosing. From 3 we are choosing 2 women. Second team has gone away. Now this is the third team. Okay, for the third team, okay, let's see what are left. 3 men are left. Actually there are 3 men left. So out of 3, because 4 have gone away, so there remains 3 men. 3 out of 3, 3 out of 3, and there is only 1 woman left, because 2 plus 2, 4 went away. So there will be 1 out of 1 choose 1 into 1 choose 1. So these boxes indicates, look at this, let me form the boxes. This is for the third team, and this is the second team, and that is the first team. Same, so is in the first possibility, this is the second, and this is the third team. Remember, this is one of the most twisted question of this paper. Then then we are going to write the solution. Number of selections. Okay, so number of selections, let us write number of selections. Number of selections, okay, is equal to, first of all, let us write 7 factorial into 7 factorial into 5 factorial. 7 factorial into 5 factorial. Then the denominator is going to be 3 factorial into 4 factorial. 4 factorial into, I am avoiding multiplication symbol, you can use if you wish. Then 1 factorial into 1 factorial into 4 factorial. This is for the first team. Okay, I am just ignoring multiplication symbol due to the shortage of space. Then for the second team, it is 4 factorial as well as 4 factorial is numerator. 4 factorial into 4 factorial. Denominators are 3 factorial into 1 factorial. Okay, here we skipped one important uh, concept, which is, look at this. In the first team, if we look at the first team, we have chosen, this is the first team. First team can go, look at this here, this team can go, sorry, this team, the first team can be in the third case, and third team can be second case, and first team, second team can be in the first place. That means in 3 different ways they can also be chosen. So we will have to multiply by 3. Okay, so let me change the ink. So we have forgotten to multiply by 3, because there are 3 vice versa, they can interchange their position. But don't get confused that this is not arrangement. But first time we can choose 1 man 3 women, and second time we can choose 3 men 1 women. That means in different ways, in 3 different ways, you can choose the teams. So is the second cases. So 3, in 3 different ways their teams can be selected. Well, we are in the second teams. 4 into 4 factorial, 3 factorial into 1 factorial, 1 factorial into, please don't get confused, I am avoiding multiplication symbol as I don't have sufficient space to write. That's why. So 3 factorial into 1 factorial and 1 factorial in, again 3 factorial into 1 factorial, because they are virtually same. 1 factorial means 1, I am avoiding that. Then for the next case, third team, look at this. From 1, if we choose 1 man, that is only one way, and from 3, if we choose 3 women, that is also one way. So there is no necessity of writing 1. So it is actually 3. Okay. Then we will write the result. After that, for the second case, okay, plus, we will add up this plus, it is 7 choose 2. So 7 factorial and 5 factorial into 5 factorial. So it is 2 factorial into 5 factorial for the first one, and 2 factorial into 3 factorial. 2 factorial into 3 factorial for the first team. Then the second team, 5 factorial, numerator is 5 factorial into 3 factorial, 3 factorial divided by 2 factorial into 3 factorial into 2 factorial into 1 factorial. I am avoiding writing 1 factorial because 1 factorial means 1, 2 factorial means 2. Okay, then third case is as same as the previous one. From 3, if we choose 3, it's 1. If we choose 1 from 1, it is 1. So we are avoiding that. Just it should be multiplied by 3, because we know that if the first team can be chosen in the third case, third team can be chosen in the second case, or second team can be chosen in the first case. So there are 3 different ways of selecting the teams. Well, now we will use our calculator. 7544 is the numerator. 7544, 7544. Okay. Denominators are 3414. So 34433. Oh, there is one 3 in the numerator. Let's not avoid this 3 in the numerator. There should be a 3 into 3 into. Let us be sure of the denominator. It is 34433. 34433. 34433. So this is 3 factorial, 4 factorial, three factorial, 4 factorial, 4 factorial, and 3 factorial. So two threes and two fours. So in denominator there will be 1, 3, 2, 3, 3, 3 factorials and 2 4 factorials. Okay. So 3 factorials, 3 factorial. So there will be another 3 factorial. Number of choices is 8400. Let me write this 8400. 8400. Well, then the second case, if we do addition, there will be addition symbol, and it is going to be, well, 7 factorial 7553 are the numerator. 7553, 75, then again 53. Factors are 2 5 2 3 2 3 2. That means how many twos are there? 4 twos, 2 threes, 1 5. So 4 twos. Actually 2 factorial means 2. So it will be 16. 4 twos are 16. Then 3 threes are 6 6 36. Okay, let us write 4 twos, 2 threes, 1 5. Okay, 4 twos. First of all, we will divide by 4 2 factorials. So this is 2 factorial. Again, 18,900. It is 18,900. 18,900. So no number of total selection is going to be equal to what? If we add up 18 plus 8, that is 27,000. It is going to be 27,300. 27,300 is the total answer. Remember, as I have told, this is the most complicated part of the solution of this paper. So please be very careful. The maximum possibility of making mistake is here. You may forget to multiply by 3. Remember, these 3 should be, because 3 different ways the teams can also be selected. That's why both the selection should be multiplied again by 3. Well, let's move on to solution number D. D says the 7 men stand in a line for a photograph. Two of them are brothers, George and Harry. How many different arrangements are there of the 7 men in which there are exactly 2 men between George and Harry? Okay, this is not difficult at all. First of all, we will have to write George and Harry are two brothers. So let us see G. Then in between them there will be exactly two, and then there comes Harry. So 4 members have already gone away. There remains 3 to be 7. Okay. So number of arrangements, we can write number of arrangements. Number of arrangements is equal to, look at this, total except George and Harry there are 5 members. So 5 factorial ways they can be arranged. 5 factorial ways. This rest of the 5 members can be arranged. After that, look at this. These G and H, George and Harry, they can also interchange their position 2 different ways. So 2 factorial. Now, if we make a box of this, suppose this is a box. Okay. So this position can be, this box can be over here, there, as well as there. Okay, so total there are 4 possibilities of changing their position. So let us multiply by 4, not 4 factorial. Remember, this is just they can change their position in 4 ways, not 4 factorial. So 5 factorial means 120. 2 factorial means 2, so 240. 244s are 960. So there are 960 ways of arranging them. This is a very simple question. For arrangements, we apply the permutation concept, and we did so. So these are all about these 3 solutions of this question. Among these 3, again I'm repeating that number C is the most complicated question, most twisted question. Let me show the first part once again. So thank you all for being with me, and may Allah bless all of us with beneficial knowledge which will make each and every person of the world knowledgeable, especially in maths and science. Fi amanillah. Let me show the next page.